Oh, hi, thanks for joining me here in my shop. I'm about to go another step with this tube testing jig rig setup I've got here. So the last video I attempted to determine the GM of the tube by doing what's called a static test, where you just change the voltage on the grid and take note of the change in current through the plate. So I got a number, but I'm not about to consider that number to be valid. But I'm going to go to the next step now, which is to set up to do a dynamic test of the GM. This involves applying a signal on the grid and then measuring the resulting signal on the plate circuit. So let me just go over what I've got set up here. So everything is basically the same as it was, except additionally I have a signal input coming from this signal generator, which I'm going to switch on. I'm going to set it to a audio frequency here, which it is. It is actually set to an audio frequency. Let me raise it up a bit. So that's about 700 hertz. So that's a fairly high tone if we care to listen to it. I don't plan to listen to it, I plan to look at it. So on the scope, I have in both channels on the scope, put them both on, you have the two scope leads coming down here. One is going to look at the grid signal and the other is going to look at the plate signal, and both of these have been isolated by capacitors. So you can see one of the capacitors here, and the other one is under this bag here, which you have a hard time seeing, but there's some exposed wire here with B+ voltage on it, so I've thrown this bag on top so I don't get a shock. But there's a capacitor under there also. That's to make sure DC doesn't end up on the scope. It's not the end of the world if it did. Whoops. But I put capacitors in anyway. Okay, the signal level coming out of the signal generator is unknown. We would have to measure it. So hopefully I've got some meter here available for measuring that. So just on that score, the grid is here. The grid potential, have I got a meter on that? This is the grid potential, this yellow meter. Okay, I'm going to flip the power supply up here onto standby. So that should start some current flowing into the heater. I see this meter popped a little bit. So it should be 700 milliamps. Here we go again. Oh yeah, that's right. Now I've learned my lesson. There we are. Oh, it was almost exactly 700 there. So it's still heating up and dropping off a bit. I have a way to solve this problem of the low current here. It should be 0.7, it's 0.675. Actually, that's not very low. That's not much. 0.7 is the ideal current, though. Okay, so on the scope here, let's get this set up. Okay, so I'm just going to move, this is the upper one, I'm going to move it upper so we can tell them apart. And then the lower one, I'll move this lower. So one of them, I don't know if you probably can't see this on camera, but this one's already showing some radio type interference with it. So I have no capacitor, no resistors involved in this at all. Probably I need to stick some resistors in to knock down some of this. So which one is that? So this is the lower, is this the lower one? Yeah, that's the lower one, So that's looking at the signal coming on the grid from the signal generator. So if I raise this a bit, we should see something here. What speed are we at? Slow it down a little bit. So this is the input signal to the tube. And the tube has no B+ on it right now. The input signal is around, see, this is only 50 millivolts. It's very, very low. Let's jack this up to, so this is 1/2 volt per division here. So now we're looking at about 1.5 volts peak to peak, roughly. We'll turn it down just a bit and make it 1 volt peak to peak. How about that? And that way it gives me the impression I'm doing something scientific here. We'll look at the output now. So this is on AC. We'll put this on AC. Shouldn't be any real DC there. Turn off that one. Turn on this guy. So here we are. Absolutely nothing. And that's what you would kind of expect because there's no voltages on here yet. Which I'm about to do. Okay, let's crank on this guy. So this is plate current. I want to keep an eye on that. This is plate voltage. I want to turn it on. That's for sure. This is handy. This is a handy meter on the end of this. Whatever I want to poke, I can see on here. So this is now reading the voltage. I think this is until I put the power supply on. It's on standby right now. We don't get anything here meaningful. So I'm gonna drop the plate voltage. I'm gonna start with essentially no plate voltage. Here we go. Okay. So we see I got a grid bias of -14. No current flowing. No voltage on it. No signal coming out. Signal going in. Okay, I'm going to start raising the plate voltage. I want to watch the current here. I don't want it to go too high. And I think that's all we really need to keep an eye on. Nothing else should change too much. So current and voltage. And watching the scope. Okay, a little bit of voltage there. So you can see the DC voltage affecting the line here. This is set to AC, so you're going to see the line kind of pop up as I raise the B plus up. So right now the B plus is around 500, around 75 volts. We have a tiny amount of current flowing. Let's go higher. Which knob should I turn? How about this one? There we go. Now we're getting some current. We'll stop around 15 milliamps here. Okay, so we got about 15 milliamps flowing through the tube, according to this meter. We're getting that with a voltage of a little over 150. That's good for now. So I don't see any output signal here. Let's make this more and more sensitive. Absolutely no output. Now, the reason for this is because I'm not really looking at the output from this tube. What I'm really looking at is just the supply to it. Even though the current may be going up and down in accordance with the grid, it's not causing any voltage change that I can pick up and stick on the scope. So at this point, I really do need a plate resistor in here. Putting in a plate resistor is going to just change everything. It'd be great if I could see the current. Again, the only way to do that is with some kind of plate resistor. Now, I can afford to put a small resistor in the plate, small relative to the plate resistance, the so-called plate resistance of the tube, which is really a combination of factors that interfere with the tube's ability to push current through itself. Everything from size and dimensions of the plates and the position of them, cathode, all that kind of stuff. It's all involved. But if the output resistor is very low value compared to the so-called plate resistance, then it shouldn't change the operation of the tube much at all. So look down here, plate resistance approximate is 80,000 ohms. And they recommend here a load resistance of 7,000. So about a tenth. That's exactly what's going on. 7,000 is what they're suggesting. Now, I have a decade box. What we can do here, because we know how much current is going through. I want to protect the resistors inside this box here. I don't want to fry them up. We can put the plate current through this box, and we can adjust the resistance really easily. Now let me think. That's a dangerous thing. So it's I squared R. So this is a very small number when you square. This is 0.018. Squared is even smaller, 0.00 something. 0.00 something times 300 is getting you down around, wouldn't that be around a watt of power? And in here, I think I've got mostly 1 and 2 watt or 5 watt resistors. I can't remember. That's the problem. So let's see. This resistance is not going to affect the current flow in here very much. So I'm probably going to get the 18, no matter where I set this, until I get up into the higher ranges. So do a more careful calculation. I should have a calculator in here, really. So 18 milliamps. That's 0.02, let's say 0.02 squared is 0.004. 0.004 is basically 0.004 times, we start at 1,000. It's an easy thing to calculate. So 0.04 times 1,000, 0.004. Sounds like 4 watts. Sounds like a lot. Is that right? 0.004 times 1,000. Yeah, 4 1,000ths, 4 watts. Son of a gun. Okay, so here's what we're going to do. Here's what we're going to do, because I'm unsure about all this, and even though I've done these head calculations, I think it might be better for me to actually look at the resistors in here and test them for heat. You know, is anything else burning up behind me? No. Don't forget, everything's on. As long as I keep that tube plate current below 30, I'm pretty sure I should get the right screwdriver. Okay, so we can look at these resistors. You can see one that's cracked here already. Now I've replaced some of these, but I guess I missed this one. It's got a crack. It's cracked right open at the back. So I can see the selector. So the question is, are we selecting down in here? So this one would burn out on that position, 68. We don't want to go down that low anyway. I'm going to stay up around here. Here we're engaging these guys. Is that my replacement job in there? Okay, my impression is we keep it up here. We can start off. I'll keep my fingers on the resistors involved. Find out what's happening. Okay, so I'm going to interrupt the plate current. So I'm going to turn off the plate voltage. Plate current is nothing. The plate current interruption could be done here. Okay, so I need a this is current, so again, I can't be fooling around with lousy connections here. Like if it's voltage, you can get, any old connection is going to work, but for current, I'm going to make this work. I'm going to make this work for current. Okay, I have a decision here. What I'm going to do is I think I'm going to solder on one of these right on here, like this. Solder it right on and use this. So I would need one. Yeah, I gotta think about this. Okay, I think I got that sorted out now. The decade box resistors are over here. This is still reading the current flow that's going to flow through the resistors here. You can still access them. I pick them up and kind of go like that, bearing in mind there's a fair voltage drop, potentially half the B plus or more could be sitting on those. I'm not likely to get a shock though, because I'm not grounded in any particular way. I'm going to get my camera out of this schmozzle here. The other current connection is done like that, but this is a really strong clip. I think that's a really good connection. So that'll, you know, we are only talking about plate current, not heater current. The scope is still connected down here to connect the plate, so it's basically the tube circuit and the resistor are essentially in series, and I've hooked up at the join spot. That way, as the current effects take place in the tube here, it will cause a voltage to go like this that the scope can see. That's the theory. So I should be able to. Yeah, let me just change the light here. See if that helps or hurts. Now, a good question is, why is the upper, this is the plate, why does the plate look like that right now? It's probably because the plate circuit is actually very high impedance. That doesn't really make sense, but I'm going to leave that thought there. We will now apply power. And watch for current here on the sleeping meter. Here we go. Okay, we have some current flowing. Good. And look at that. We actually have an output here. Can you believe it? They actually made this work. I don't believe it. Now, this is set very low. This is very low. So let's put it like that. And we want to. We should get amplification out of this. So if we set both these on the same, let's do that. 0.5. Okay. So there's the output. You can hardly see the wave in it. Now, the B plus is very, very low. The current flow is very low. So we'll raise the B plus. Current will go up, and we'll see if this gets bigger and better. Okay, and I don't want to go over 30 milliamps of plate current. Not much happening on the. Okay, we'll stop there. So this seemed to clean up a little bit. It's still way low. Right? We're putting in a higher voltage than we're getting out. Could just be because I picked bad resistor. Oh yeah, what about the resistor? What about that resistor? I'm gonna get a shock doing this. That's a bit of a miracle. So looking at the contact, it's these ones over here. You know, if there's some warmth in there, I can barely feel it. So I'm going to change the value of the resistor. I'm going to knock it down. Let's go up. I'm going to go up. That's up. Go up again. Up. Up again. Up again. This is getting a little bit bigger every time I do that. So now I'm up at 5,000 ohms. The recommendation was 7,000. Isn't that interesting? Let's go one more snap. So supposedly this is now around 7,000. 7,000 ohm plate resistor. I don't know for sure that this is accurate. It's going to be in the ballpark though. We're feeding in a signal whose voltage level is about 1 volt. The bias is appropriate. The current flow is appropriate. Current here is a little low. B plus is still low. B plus is reading 140 volts. 250 is where this thing's supposed to be. Shall we head to 250? So 250 would be straight up on this meter, but I'm pretty sure we're going to go over here. So we'll go up until we see this get up around 30. We'll chicken out at that point. Because the fact is, I could be making horrible mistakes here because I don't really know what I'm doing. So we're at 25 milliamps. Let's hold it there. We're nowhere near the 250 yet. Well, I shouldn't say that. We're like 180. Okay, so now I'm going to back it down, way down. And the reason is the voltage supply meter on my power supply up here, which I just happened to look at, was pinned over 400. So I've never ever turned this thing that high. So how did that happen? Why did we get... Why is this meter reading so low? So certainly this resistor. Let's think about this for a minute. So I have the meter reading the actual terminal on the tube. And I've stuck a resistor in, which is no doubt dropping a fair bit of voltage. So what is that saying now? Is that saying I've got to crank the voltage up to the point where even with this resistor I still get the 250 on the plate? And it has to be the 250 on the plate. I shrink this way down and it should be able to get the voltage up here. So let's watch this meter. The supply is around 150. And this meter is saying, okay, that's the 150 scale. I'm going to go down on this resistor. You'll probably see that voltage go up every time. This current also dropped way off. Okay, we're not making a lot. So I'm at around 500 ohms now down here, as opposed to the 7,000 number written in the book. 500 ohms. This is low. This is still very low. Okay, B plus up. So the supply up here is saying 200. This guy is saying 150. He's saying 16. I'm saying, and we're getting no amplification here. So it's probably just because I don't know what I'm doing. That's probably the reason behind all this. So since the measurement of GM is really about variations, if you're going to do a dynamic test. So we have the grid varying 1 volt, peak to peak. And we have the plate varying almost nothing the way I have it here. And we can't see the current variation. Can we? If I put this on AC current, what would happen? That's a good question. Let's try this. So next step up is 20 amps. Then the next step is 20 amps AC. The next step is 200 milliamps AC. It says there's nothing there. Well, there is practically nothing there. There's practically nothing there. 20 milliamps. Okay, so we got a little reading on the meter now. Does that mean anything? So I'm just swimming around in circles at this point. Again, B plus is running around 150, so this has dropped to nothing at all now. still see a little bit here. Let me multiply this by 10. I think that's multiplying it by 10. Milliamps AC, nothing showing. Oh, what frequency are we running at? So we're running this at 700 hertz right now. Jack it way up. Okay, let's try that. So I'm just going to jump it up by a factor of about 10. So we're going to go to 7,000 hertz here and see what happens on the scope. We get basically the same result. Yeah, it's about the same result in terms of the signal strengths here, so that didn't really help. At 700, maybe out of the AC range of this, so let's take it down and see if this starts showing something. Down in frequency. Watch the scope go in there. The scope must be triggering on the line or something. Yeah, it is. I have a lot of trouble making the scope trigger. Okay, doesn't like channel 2. There we are. We can trigger on 2. Still kind of shaky. Still nothing here. This is you probably just can't do it with this meter. It's probably the name of the game. How can we ump the current flow? We don't know what's happened to the DC current now while we're doing this. It's easy to find out. DC current is still 16 milliamps. So I think if we put a resistor in that's roughly the same as the plate resistance, so it'd be 80,000 ohm resistor. 80,000 ohm resistance. So it'd be 80 times 1,000. So let's try that. So I'm going to flip this to times 1,000. So it's going to go from 500 to 500,000. So watch what happens here. Well, it got bigger. Got quite a hum in it there, I think, what we're seeing. And then I want to... We're at 500,000. Yeah, I'm aiming for half of the value of the tube. So 80,000. I have a hard time remembering what I'm doing. Oh, come on, you crazy meter. Scare the heck out of me. Here we go. Off. On. I'm smart enough to push this button too. See? I'm getting it. Okay, back to this going down. Right, 80 be way down here. Look at the current flow. It's dropped to almost nothing. So you have a basic, what I think is around 100,000 ohms working against the tube. The tube current has dropped. Wait a minute, am I doing this right? Yeah, tube current has dropped to almost nothing. The tube plate voltage has dropped almost nothing, so it's almost in cutoff. It still seems to be doing something. Is this false? Let's kill the B plus entirely and see what happens to that upper line. It'll come back. No, it's not false. Okay, we'll raise the B plus back. I'm gonna... Yeah, that's okay. Leave it on AC. It'll just make trouble. Okay, let's see if we can jam this thing all the way up until there is some pretty decent voltage on the tube. So, no, with a great big resistor here, you cannot push enough voltage onto the tube. So the tube is running with only, what? 500. It's under 100 volts now. It's quite the quandary. Is it because I'm letting too much current flow through this tube? It's only 2 milliamps now. Well, let's do this. A lot of tubes, not maybe this kind of tube. This is an output tube, but A lot of tubes, you reduce the negativity on the grid, you increase the gain of the tube for reasons I can't really explain right at the moment. So let's prepare for that. We'll go up here. These are now both set to 0.5 again. I'll crank down this B plus voltage. Got to keep an eye on this while I'm doing it. Did I say B plus? C minus. Okay, trying not to blow up everything here. 2.6, 2.7, not doing much of anything. Okay, so by now the voltage is down to almost nothing, and we still have not much there and not much here. I put such a big whopping resistor in there. I think I had this all set up correctly. Maybe I've been doing this with a bad tube all this time. No, that's not the case. Definitely not the case. Well, I think another pile of stuff here to think about. My next step, I will get better control over the heater and heater current by using a different supply instead of relying on the fixed 6.3, not really 6.3 volts coming out of here. And I will put myself in a position where I can make this either run at 6.3 exactly or run with the exactly correct current, 700 milliamps. It's not going to change much of this other stuff. I really got to understand why this didn't come out bigger than this. Okay, that's where I'm at now. Hey, thanks for watching again. This is to force my head through a certain, I don't know what they call it, die. So I come out the other side smarter. Maybe die is not the right word. Okay, we'll see you on the next video.